We just hit our column here. We kind of did a little formula here to figure out what the new case is reported here. And so the next thing is this a linear pattern here? And so what I'm going to do is, for the time being, I'm going to hide these columns because they're going to distract us. Okay, so pretend that this was, I'm going to write this up on top, pretend that this is your x variable and your y. It's like an XY chart, right? So if I did that, and let me just hide this row for the time being, and you guys don't have to do this, I just want you guys to see this real quick. If this was an XY chart, is this a linear pattern? Pause the video. I want you to think about this real quick. All right, hopefully you paused it. Now, we can use the slope formula, y squared, or y sub 2 minus y sub 1 divided by x sub 2 divided by x sub 1. So basically, for every day that goes up, it goes up by 1 here. Whereas this is going up 1, 3, down 1, up 4, down 7, up 17. Then it goes up 18, up 15, up 1, down 5. So this is not a linear pattern, and hopefully you recognize this. A linear pattern constantly goes at the same rate. So that being said, this is not linear, okay? If it was linear, that means every day there would be, let's say, 5 new cases. So it might go 1, 6, 11, 16, 21. It would go on and so forth like that, okay? This is not happening. Okay, so this is why we know that COVID was not a linear pattern. And as you can see, it's exponentially growing. I guess I'm prematurely calling it exponentially. It's growing really fast. And as you can see, once it gets to March 9th, we almost tripled and doubled, and then, there's different looks to this. So that being said, this is not a linear pattern, and in your assignment, it's not a linear pattern because it's not going at a constant rate. And you can identify this by grabbing 2 points, aka a day and the new cases, and you can, subtract it and find the slope between those two, and then divide it. So you would use that. So if you want to look at like a linear pattern, I just Googled it. This is what I'm talking about. Okay, this is a linear pattern. This constantly goes up 12. This constantly goes up 3. So 12 divided by 3 is the slope 4. So this is going at a rate of 4. So for every time y goes up 4, x goes up 1. Here's another one. It goes up 4, up 4, up 3. This one's different. So this one's not a constant rate of change, whereas this is 7, 7, 7. So I'm just showing you an example of linear patterns and not. So realistically, that would be linear in a technical, okay? Maybe you can identify as linear. All right, so the next thing is, how do we know if it's exponential? So what I'm going to do here is I'm actually going to unhide. Okay, whoops. So I'm gonna get that back, and I'll leave that for the time being. So you can look at this as an XY. So the next thing, what we can do, if it's exponential, and we haven't talked about this, you can divide what's happening in between all of these. Okay, and so this is what we can do. If it's exponentially growing, it's going like times 3, times 3, times 3, times 3. So let me Google this. So let's Google exponential growth table. Okay, let's see if we can find a table that identifies exponential growth, and you can see how this goes. Here's a good one. Here's y equals 9 to the x power, okay? 9 is the base. Depending on the input of the y, it goes up times 9, times 9, times 9, times 9, times 9, times 9. You can notice that this exponentially grows. But if we're just given the table, how can we find out it's 9, okay? And this is what we can do. The inverse of multiplying by 9 is we would divide. So if you knew what that number was to get from 1 to 9, this is an easy one, you'd just multiply by 9, okay? If I knew 9 times what would get me 81, it's 9. If you don't know that, what you're going to do is you're going to divide. 9 divided by 1 will get you 9. 81 divided by 9 will get you 9. This will show you an exponential growth. So if you take one data set and divide it by the previous, that will give you the rate of it in an exponential one. Whereas linear is you're subtracting. So let's go to this, okay? What is the rate of this? So this cell is going to identify what this is divided by, I'm going to put H5 divided by this term. So what that means, no, I don't want to do it. It means 1 times what would get me 2? 1 times 2 would get me that. 2 times what would get me 5? Tough one. So let's think, instead of going 2 times what gives me 5, let's go 5 divided by 2. So what we're going to do is we're going to take this cell divided by the previous one, 2.5. Same thing here. We're going to put equals 4 divided by, I don't want to put 5. I want to select the cell. So it's 0.8. So you see how this is, it's not going constant. So right now I can't say it's consistently going at an exponential rate. But what we could do is we can continuously do that. Let's try one more. 8 divided by this cell. Okay, and I'm not saying 8. You got to put the cell numbers there. Okay, and I'm going to hit enter. Ooh, so it goes back to 2. So this is what we're going to do. We're going to copy and paste this for all of them and see if this is consistently at the same rate. So now we're looking at a situation. Okay, I want you to put exponential rate here. We're going to go here. We're going to center it out, okay, just to kind of make it look nice. What we'll do is we'll click on there, and then we can talk about the numbers. We can make sure we just go to a couple numbers because we don't need too many. So I'm going to click on that, and here we are with this. This is the exponential rate. Stop the video in a moment. Does this constantly go at the same rate? It does not go at a constant rate, right? So if you had to make a guess, is it more exponential or is it more linear? Well, this case is not a clear-cut exponential rate. It's not a clear-cut linear case, but I could assure that it's closer to an exponential rate than it is a linear, okay? And so what I would do, and I'm not saying this is what we do in the real world, but if we, in our class at TAF, we can just say, hey, what would be the average of this? So what we could do is maybe if we want to find the rate of the exponential, if I add all these up and I divide it by how many times I did, maybe it'll give me a rate of an exponential rate, and I can get an educated guess. I'm not going to say it's going to be the best guess, okay, or it's going to be the correct answer. I can look at it as an exponential rate. So it's just a thought, right? So we can average all these numbers out. So how can we do this? So the average exponential rate, okay? I kind of want to do this. So what we're going to do is we're going to say equals, I want to add all of them up. So we're going to take the sum. You're going to put equal sum, open parentheses. You're going to click and drag all the numbers you want to add. So we're going to add all these up, okay? When you're done, whatever that adds up, you're going to take it and divide it by how many numbers there are, okay? So I'm going to just put a clear number here, right? So if there's 5 cells, right? Actually, here's a little trick that you guys can do. I'll show you guys on the bottom. If I select all this, let me get out of this. I'm sorry. All right. There's a little feature here. If I highlight all this, you have these little things. How many? There's 29 of them. Some. It gives you all these quick things. Boom. There's the average, 1.5. Kind of shows on that little feature there. So what I was just trying to get to, if you click and drag, sometimes they give you some nice little features here. You can look at these. The average is 1.45. If you can add them up, it's 42. it tells you the max and minimum. There's 29 numbers. So in other words, what I'd like for you guys to teach you, there's 29 numbers. So what we're going to do is equals sum, open parentheses, drag it, add all of this up. We're just going to find the mean, close parentheses, divide by 29. And we can go there, kind of clean up the numbers here. We don't need too many decimals, but we'll just say it's 1.45 is the average rate if we considered it to be exponential. Okay, last part to this that I want you guys to do. I'd like for you guys to copy the days. Okay, so this is what we're going to do. So now we got an exponential rate going on here. We could have done this with the linear. We could do that with the linear too, so we can figure out how many new cases that we have, and then we can divide it. So let's do that. Let's do linear rate. Okay, although it's not linear, I would argue strongly against that. You can take the same idea. We could take it and take the sum of all the new cases, which I really don't think this is worth our while. I'm going to omit that idea. I'm just not, what it's going to do is just going to give us the average rate of change if we made it a straight line. And I guess maybe we should do that. Sorry. So let's take it. It's more for the sake of, let me refresh this. So equals sum, open parentheses, all the new cases. Okay, close parentheses, divided by, and then see how there's one extra number here. I think there's going to be 30 here, but I'll confirm. So if I highlight this all, it should tell me on the bottom here, 421, there's 30 numbers. Because see, we're missing one right here. So I think that's a good rate to kind of do that. So if you wanted to think of it as a linear, the average linear rate, we can say it was going up by 421 per day. Whereas if you thought it was an exponential rate, it's going by 1.45 every day. Okay. All right. Here's a couple nice little features there. You can kind of box this out, organize it, boom. We can bold the little title here, Command B on my MacBook. All right, and here's the last thing that we're going to do. So I want this all on your paper at this moment. Exactly what I have. Let's graph it, okay? Let's pretend we didn't know any of this. We're going to highlight days and new cases. We're going to highlight it all. And once you highlight it, you're going to go to Insert. And you're going to, where'd it go? We're going to insert a chart, okay? And this is kind of a nice chart to do. So if you're not convinced on what it is, okay, we can leave it. And the best thing about it is new cases reported versus day. So what it has here is each day it tells us your specific. All right, and this goes by 500. On the right here, you can kind of change up some nice features here. You can make different colors. You can make a trend line, okay, a linear trend line. You can make an exponential trend line. And so you can look at a polynomial. You can look at a log. These are some nice things. So do you think it's linear? I don't know. I don't think that follows that nicely. I think the best thing that we can do is exponential. And I feel like that is the line that best fits what we got going on here. And so that being said, I would like for you guys to put a trend line. So on the chart editor on the right side, under where it says series, if you don't have series open, I want you to click series and you go down and you look for the trend line. I want you guys to click on that. And I want you to just kind of fiddle around with that and kind of believe yourself. So we can make that color. Let's make it something different. Let's go with a red. Okay, so we just, ooh, what did I do? I clicked something. Oh, I put all the data labels. Okay, so we can put that there as well. Might be too much information. All right, so that's it. That's all I would like for you guys to do. You can drag this for your classes, any arguments that you want to make. And we're going to talk, let me scroll up, let me bring this up. And so if you kind of zoom out of here, Here's a nice little data set of an exponential growth that we got going on here. I think that's the line that best fits. Cool thing about this is if you're writing a paper, you can download it, you can copy the chart, and you can put it on a Google Note. So in the end, what I'd like for you guys to do, this is what I want to see. I want you guys to turn it in. This is part 1 of our project, just creating Google Sheets. And then we are going to dissect this and kind of answer some questions. All right, guys. Thanks for your time. Appreciate it.